Okay, so today we're not going to have like the double screen where I'm writing because we were really just going over some theory behind gas laws. You may have been exposed to this in physics. It might be a physics 2 thing. I'm not sure about the curriculum in this school. But we're just going to learn about gases, how they behave, and what will increase and decrease gas pressure. So after today, I want you to be able to explain the factors that affect gas pressure. I want you to be able to describe real-world experiences that relate to pressure, temperature, and volume. And I want you to be able to predict the behavior of gas if you change one of its variables. So kinetic molecular theory, it's just saying that gas particles will move in a straight line until they collide with another particle or obviously hit the wall of a container, and that the motion of the particles is constant and random, and that there are no attractive or repulsive forces among the particles. So four of the variables that we use to describe a gas, and these will be the variables that we will be using in our calculations starting in the next subunit or lesson, is pressure, either in kilopascals, millimeters of mercury, or atmospheres. And then volume, which we'll use liters or milliliters. Temperature, which is always in Kelvin, and the amount. So we will be dealing with moles, which is why I told you guys it was a good thing to wait until after the moles unit to start this unit. So you will be able to do the calculations. So factors affecting the pressure. So if you add or remove gas, so if you add gas, you will add pressure. So I was going to show you guys a balloon. So basically I had a balloon, but it was too difficult to blow into it because it was one of those long ones that you make animal shapes out of. So I can't do it. But if you were to blow into it once, you have a certain amount of gas. That would be this one on your left, okay? But if you were to blow into it twice, you would have twice the gas particles. And let's say the balloon didn't expand, you just had twice the amount of gas in there. Then you would have twice the pressure, okay? So think of it that way, or maybe think of it as blowing up a basketball once the basketball is kind of full. If you were to double the gas in a full basketball, that pressure would be huge, okay? So it's a direct effect. You double the gas, you double the pressure. So, and the way it increases pressure is these particles are colliding with each other. So the pressure is created when the particles are colliding with each other. They're more likely to collide with each other if there are more particles. So if you add more gas in the same amount of volume, they're going to collide more often. So like I said, this is a direct relationship. So if the number of particles double, the pressure will double because of the collisions are doubling. So a real-world example is the whitewater rafting. You can inflate it too much and it'll pop. If you don't inflate it enough, it won't float. So yeah, that's it. So another factor that affects gas pressure is changing the actual volume of the container. So let's say the volume of a gas is decreased, then the pressure will increase. So for example, let's say you had a balloon, okay, or a basketball. And let's say you squish the balloon or the basketball to half its size. So those gas particles are going to be able to collide more often, so the pressure will increase. So if you have the same amount of gas and you squish the balloon or the basketball down, the pressure will increase. Okay, so if you have half the volume, you have twice the pressure. So that's called an indirect relationship. And so again, particles are closer, they're colliding more often, and so you have more pressure. So a direct relationship means that if you double the something, that something else will double because of it. Indirect means if you halve something, something else is doubled. So it's basically an indirect relationship. If something goes down, it'll go up, whereas a direct relationship, it would be like up and up, or down and down. Okay, an example of this is if we open, so an example of the next pressure. So if we increase the volume, with the same amount of gas, the pressure will decrease. And it's kind of like opening a Coke can. So if you have a Coke can and you open the lid, you notice the gas escapes really quickly. And that's because it was under pressure. You have opened the lid and now the volume is increasing. So the pressure is decreasing. Okay, so that's a real world example of that previous one. Another factor of affecting gas pressure. So we first talked about doubling the gas, which will double the pressure. That was direct. Then we talked about halving the volume, and the pressure would double. That's indirect. Another example of that would have been the Coke can, where you increased the volume and the pressure decreased. Another indirect example, relationship. Now, this one is we're talking about temperature this time. So if we increase the temperature, we are increasing the kinetic energy of these particles, making them collide more often because they are moving more fast. So if you double the temperature, you're going to double the collisions and you'll double the pressure. Okay, so that is a direct relationship. So the particles are moving faster when they're heated. They strike the walls and each other with more force. Pressure builds up. This is a direct relationship. Temperature is doubled, pressure is doubled. An example of this is an aerosol can, so like hairspray or spray paint. If you've ever left one in the car and it's exploded before, if it gets too hot, then they can explode, and that's because the gases inside the pressure are vibrating or colliding so much that the pressure is increasing, and the higher the temperature gets, the higher the pressure, and it can potentially explode. So that's a real world example of that.